All right, I'd like to call this meeting of the Homebrew Robotics Club, August 30, 2023 to order. I'd like to thank Florian Pastino for being here. Let's see if we can get a shot of you there, Florian. You're around here somewhere.
Yep.
There with me. HPRC maker. Oh, that's perfect. All right. Sorry. Let's do this. Let's make that. Okay. All right, we generally start these things off with some robot news. Does anybody have any robot news they want to report? Oh, I do. I posted on the Homebrew Robotics Club mailing list a link about how long will it take robots to do your chores. I'll just put that link in the chat here. And we'll be sure and get the chat in the mailing list somewhere. Is everybody on the mailing list? That's where you get all your Homebrew Robotics Club news. But anyways, yeah, in the category of humanoid robots, I see this new one from a company called Apple Trunk. And let's see here. But there's a lot of humanoid robots coming down the pike, it seems. There's one I read about a company in Canada called, they're making a robot called Phoenix, and you've got Boston Dynamics Optimus, or I should say Tesla's Optimus and Atlas and Cassie. See if I can do a share screen on this for what it's worth. It looks like my browser's going to give me a hard time. Anyways, I've got a link. It looks like there's a lot of humanoid robots coming down the pike. Like I'm telling you something new. But I think that the humanoid robot, that's the end game. There's going to be a lot of good wheel-based robots and so on and so forth coming down the pike before we get there. But we'll eventually get there. Any other robot news? Anybody want to
I got
report?
something.
Go ahead, Thomas.
Yeah, I made a offer to buy one of those Hanson Robotics Little Sophia. I guess they're dolls, but they're based on the big Sophia the robot. And they said they're gonna actually have some in production and releasing them to the public by the end of this year, which is 3 years after they offered them. So I can't complain too much. I only paid $200 for mine, but when I get it, then it'll be something worthwhile.
Can you dig up a link for that?
Yeah, I can look for that.
Cool. Also, this Unitree's new go-to quadruped looks interesting at $1,600. The $1,600 quadruped robot. Let's see. I may have the. Here we go. Let me try and share my screen. See how that works out.
I read that it's actually $1,600 plus like $3,000 to ship it. So
Oh, one of those. That's a lot of the nice. A lot of the China stuff is like that.
the battery and all of that. It's
Actually, let me find this.
So it's $1,600 for the robot and $3,000 for shipping, eh?
It was something like that. It was like by the time you're done, it's like, okay, that's actually not as inexpensive as it looked like initially.
Still exciting stuff. That's the thing about this business is it just gets better and better.
I need to do a biopsy on our dog, and that's going to cost me $3,000. So
Yeah.
this is cheaper.
Right.
Not as nice, but
Yeah. Yeah, I just got one of these little, this cute little robo dogs, like RoboPet or whatever it's called. It's like wheels for feet or whatever, one of them little things. It was a gift last night. I have not tried it out yet. No idea what it's capable of, but they're cute looking.
What's that, Ralph?
I got one of these robo pet dog things as a gift last night. You know, one of these cute little things that has like, I think it has wheels for feet. You know, I forget what it's
Yeah,
called, like
You need a
Robo
pet. That's what you need.
something, you know, something like that. And yeah, I haven't fired it up. It's still in the shrink wrap, but you know, maybe next month I can do a full detailed technical analysis for
Bring it
for
in
you
for
guys.
show and tell.
Exactly.
I
Yep.
just put in the link. India managed to land a rover on the south pole of the moon. And the Russians, I believe, ordered theirs in last month. They crashed, but India got a. And let's see. Here's the article. Here, I just put that in the chat. It seems that they've discovered sulfur, and of course, the deal with getting to the south pole of the moon is that there's water just under the surface, from what I understand. And of course, we had a presentation on the Viper mission by NASA that's going to be next year, where NASA is sending a rover, the Viper mission. NASA is sending a rover to the moon, south pole of the moon.
You see that EvoBot link? That looks pretty impressive.
What's that?
Nice.
Is that the link you put in there, Stephen?
Yeah.
The EvoBot's pretty. I saw that too. That's really interesting.
Yeah, it looks really well done. If it really works that well, like it's almost hard to believe. I don't know about the name because it sounds really close to EvilBot.
I like that.
To me.
Say, Cam?
Yes.
Yeah, just a follow-up on the Indian lander. What they found was they put a probe into the soil, and they found that way just like 2 or 3 centimeters below the surface, that it was like minus 80 degrees centigrade. Which, because of it's on the south in the craters, it gets very cold, and that's great because the ice will stay there, right?
Yeah.
So it's going to be prime.
Without supplementing it.
Yeah. So they'll be prime hunting for water.
And the interesting thing about that project is that the total funding for them to land a lander on the south pole of the moon was less than a number of recent movies.
Yeah, or less than certain rockets we won't name on that.
Well, yeah.
Seriously, it's like 200 million. Something like
It's
that.
a little questionable, their numbers, because
Yeah.
they get a lot of free help from government, other
Sure.
government agencies.
Yeah,
Right.
yeah. It probably.
So here's
is huge.
here's your Evo robot, Stephen.
Yeah, that's should play the video for it. Yeah, let's see if I can.
I've got it queued up. Oh, you got it. All right, good.
I'm afraid I can't turn the audio on for it, but we'll get the idea.
Clever design.
What's the purpose of the tennis balls?
I think that's for it to bounce if it falls over or runs into something. I'm pretty sure.
Yeah.
That's the landing
Okay,
point.
it's okay for the robot to fall over. It just needs to be able to get back up.
Right. But with those arms. And they quote something like 9 hours of operating time.
What?
Yeah, that's the part I'm questioning.
Wow.
I mean,
Yeah,
maybe
where's the
those arms
battery?
are batteries.
Maybe, yeah. It's all battery. A couple of motors. Yeah. It can carry beer. That's all I need to know. That's it. We're done.
It'll bring you a case.
Yeah, can it carry a keg?
What
Bonus
you don't know
points.
is how autonomous it is.
Yeah, true.
Yeah, that's a separate problem. So yeah.
Just a matter of rossifying it.
There you
All
go.
right,
They can
well.
hire you, Cam.
What else? What else? What else? We got more robot news out there?
I got that other one queued up with a little Sophia.
Go ahead.
You.
Is there any audio coming out of this?
There's
Come
not,
on. I don't know why the audio is not working.
there's not, but it's, we get the point.
This is 4 years ago. So I don't know what they had here, whether it's animation or what, but this was from 4 years ago and they're still not shipping it.
No.
Put a lot of effort into the face, if that's real. Not much else, but still.
All right, that's the Hanson Robotics Little Sophia coming soon to a robot club near you. Hey, Jim, how you doing? Jim D'Annunzio. All right, and Wayne Gramlich. All
Hi.
right, so any more robot news out there? All right, let's get into club news now. We've got a lot of things going on during the week. It's the Ross discussion group on Tuesday evenings. The Builders SIG on the penultimate Wednesdays. HPRC business meeting meets the first Wednesday, so we'll have our business meeting on August or I should say September the 6th. Mainly talk about presentations there, but if you're interested in the business of the Homebrew Robotics Club, Chaz has been posting about a Sunday meeting where he does Gazebo Fortress. Anyways, I put a link here for the HBRC mailing list. If you're not on the mailing list, get on the mailing list. It's a Google group. That's where all the robot news and information, and if you need questions answered, if this group can't answer it, it's probably not answerable. Any more? Oh, Marco, are you out there? We're the HBRC will be attending Maker Faire. Let me just get the dates real quick. It's on 2 weekends this year. Yeah, October 13th and 15th, and the 20th through the 22nd. Actually, the second weekend is supposed to be like Robot Week. So, you know, if you want to just go for that weekend, that would be fine. You know, if you're all in, you go for, it's in Vallejo this year, so it's a little different. But Maker Faire is always a lot of fun. You know, and don't be a spectator, participate. These things are a lot of fun. Also, it's a, you know, it's a deadline that forces you to create. So any opportunity you get to create, that's a good thing. So that's yo.
You said the second weekend is more robotics, or?
Yeah.
Okay,
That's
good.
what I've been told. That's what
I
I've been
didn't-
told.
I haven't seen much on their website about this particulars of like who's coming and
Well, I think
list of people, list of companies.
I think
And
as
we-
far as the details, they're still working those out, right? I think they have the big structure, but not that.
Yeah, I
Yeah,
mean,
Mark-
like,
they're figuring it out as they go along.
yeah.
The good news is that we've registered early, and Marco's running it. So you've seen that Marco in the mailing list. You can communicate with him or communicate with me. But you know, show up and have some fun. It's great. The price of admission is member in good standing, and bring a homebrewed robot, and guaranteed good time. I mean, these things are a lot of fun. What else? Club news? Any more club news out there? I shared the mailing list, so make sure you're on the mailing list.
And one other thing real quick, Camp, I just want to touch on real quick. Is everybody signed up on the sign up sheet tonight? And also, if you're not a member, advertise for that. It's $10 per year for the membership for the clubs. It's a great deal, and it's for your whole family if you want to. You have a whole family membership for $10 a year. So and that enables you to participate in certain competitions
Yeah,
that we did
or
put on.
extracurricular
Challenge.
activities.
Yeah, extracurricular activities, yes. So the botanic, which is always fun. See whose robot can eat the most hot dogs. That kind of. Anyway, that's all. Yeah, that's it.
Ralph Hips, ladies and gentlemen, our Sergeant at Arms. Thank you, Ralph. So the next part of the meeting is what I need help with, if I'm not mistaken. So, yeah. So anybody need help with anything specific, robot question, problem? It's a good forum to put it out there.
Yeah, this is Steve. I had two questions, and I'm hoping somebody had some experience with it. Have people used MicroPython before?
It's only a little.
Only a little.
Yeah.
Can you take that code and just dump it into your normal Python code to use it? I know it's designed to be used with microcontrollers.
Yeah, I think generally you probably can, but I think there's like it has some built-in things that are direct to the microcontroller, right?
Oh.
And I mean, I'm sure it loads as a library, so
Yeah, that's what I'm gonna do.
probably some way to do either something compatible or maybe there's something equivalent. I don't know, it's a good question.
Yeah.
But there really ought to be like a library that connects to a simulator so that you could simulate something.
Yeah.
But I haven't looked into it.
Yeah, I started peeling the onion back a little bit. Starting to
Stephen, so good
Yeah.
to see you.
Pardon?
So good to see you.
Yeah, how you doing?
I'm doing well, thank you. We survived
good.
the hurricane. It was terrible.
Yeah.
It was touch and go for a while. Hey,
Yeah,
Stephen, why
Yes.
don't you get your question together and post it to the mailing list and folks can follow
Yeah.
up with it.
Okay, and one of the quick ones, and that's I have a magnetic encoder. It's a AS5600. And has anyone ever worked with magnetic encoders before?
I bought some.
Was it AS5600 by any
I have.
It sounds familiar, but I can't remember. I definitely am going to.
Yeah.
But
If you
Along with-
wait a month or a year, you can come
Yeah.
to me and I'll tell you.
what have you had success with it? Or?
I've had limited success. When it moves small angles, it reports a good angle. But when I rotate it around a few times, it shifts by 60 degrees after so many turns.
Oh.
And I'm sure there's an answer there, but I just haven't found it yet.
I might add that we have a lot of good discussions in our help groups, the Ross discussion group, the
Right.
builders, SIG, special interest group, the voice intelligence group meets on, what is it? Is it penultimate? What Thursdays? What is it, Thomas? You guys meet?
Yeah,
The
we're
second-
meeting the last Thursday, not the penultimate. That's
Oh,
not
you're
the
meeting
penultimate.
last Thursdays. Okay. that's the
Last
voice-
Thursday.
That's the
Fourth,
voice
no.
intelligence group.
Scratch
If you're
that.
interested in specific things, the voice intelligence group and the Ross discussion group, but the general stuff is the builders SIG on penultimate Wednesdays. And of course, the general meeting is the ultimate Wednesday, right?
Camp, scratch what I said. It's the fourth Thursday, not the last, but the fourth. Because the last
Okay.
Thursday I think there can be 5
I'm gonna
Thursdays in a month.
I'm gonna talk to you and Martin about that, but okay, the fourth Thursday. Thank you. All right, what else? Any more club news out there or any more what I need help with?
Oh, I had a just a question about Robo Magellan and starting to research that, and I watched the the video or the lecture back from 2017 by our own Marco, and other than
Marco
that,
Walkout.
yeah, other than that, I guess there's a lot of hits on the internet of people building Robo Magellan, so I'm looking at those. But if there's any other specific good places to kind of get a build that was some sort of how-to or some good write-up on people's builds, then that's a good place to start.
I hate to honk my own horn, but I have a Robo Magellan chapter in my book, Homebrewed Robots.
Oh, okay, yeah,
Yeah.
I think I
Yeah.
saw that chapter, at least an early version, but I have the book. I'll see if you've changed it.
Yeah.
But yeah,
Jim, yeah, if you post something on the alias, I've done Robo Magellan several times too. I can try to help out.
oh yeah,
So,
thank you.
yeah.
Very fine. What else I need help with? All right. Well, we're a builders club, right? We're not the talk about robots club, regardless. Stephen, do you want to introduce Florian?
Yeah, absolutely. So Florin Pestoni, is that right? CEO and co-founder of In Orbit. You have the storefront in Mountain View. Is that your headquarters?
Sure.
Okay. And so they're working on basically like dashboard and monitoring and control of a presumably the cloud service that's controlling your robots wherever they are, right? And monitoring them and providing your, that interface. And so you're the middleware and the control system. And so he's going to talk about all of that and what they do, how they do it, how we can use it, all that. And I've been at an event at your storefront, which was pretty interesting. You have a nice demo space there, and a few example robots running around. So, yeah, should be interesting. So we look forward to it.
Awesome. And our goal heading to of robots keeps growing.
Nice.
And I'll get into that, but we do open to the public for a few hours a week. Sometimes a few hours a day, if we're lucky. So part of the idea is make robots more accessible and maybe perhaps less scary for regular people. So obviously anyone who's here is welcome to come and visit, but I'll get into that.
Okay.
One thing I'll mention is I think just around this time, maybe 10 miles from here, the Beyonce concert is starting. So if you're here, you care about robots more like than you care about
Or we just gonna get a ticket.
or you can get
There we go.
all right, so here's the plan for today. I'll do like a couple of slides just to get us on the same page. And then we have a live demo of stuff that's happening over in Mountain View. So for people here, that's just down the street. For people online, it doesn't really matter. You can access stuff from wherever. So that's the idea. Let me just get into the slides. I'm going to try to go through this quickly, but if you have questions and you want me to slow down, then just let me know. So the first thing I'll mention is we don't make robots, but we try to make robots run better. So this is something we call RobOps. If you've heard of something called DevOps, which is what makes the cloud go, we're trying to bring some of those ideas and principles to the world of robotics. So it's really not how do I make a robot, but how do I run, hundreds of robots, possibly in different locations, doing different things. Why robots? We work on, commercial robots, not so much the home robots, but, you've seen some of the challenges that businesses have out there with labor, consumer expectations to keep mounting. We believe that this new generation of robots can help, autonomous robots, smart robots. I use the term smart robots kind of like the way I use smartphone to compare it to like an industrial robot arm, like a Yaskawa or whatever. It just does the same thing over and over. These are all like sensor-based, computer vision-based robots. And what's interesting is there's robots for more and more tasks. right? You can have, like here, you can see a delivery robot, you can see an inventory robot, cleaning robot. So there's more and more of these commercial robots. And we believe that you need a way to manage that complexity. So this idea of robots, again, how do you get the people who are running the robots and the people who are making the robots to share data, share an understanding of what's going on? So we do work with both sides. We work with companies that make robots, work with companies that use robots. And you know, again, these robots that I mentioned, they're also being deployed in all sorts of industries. Warehouses are adopting robots pretty quickly, but we're working with a very large hospital system, and they need to move stuff around all day. We're working with a agricultural company, and they need to plow the fields. So all of these are you know, part of our like little ecosystem. I'm not going to go into the software itself, but it's a distributed platform, some things that run on the robot, on the edge, in the cloud. You have APIs to build your own things on top of it, or dashboards, as Stephen was saying. We do have a free version of our platform, and it's not one of those strict things. It's free forever for as many robots as you want. Some limitations in terms of functionality, but if you have, and it works for anything from like a turtle bot to tractor, right? So if you have a turtle bot, or you have, you know, any kind of ROS-based robot or non-ROS, chances are you can make it work. So when we talk about like how people or companies, I should say, adopt robots, we've seen kind of like a consistent pattern. Most people start with this, like, okay, I'll try a robot and see if it helps. Sometimes they end up in the corner gathering dust. Other times they're successful, they move to the next phase. It's like one robot helped, many robots help more, maybe sometimes. And then it's like, well, but now we have all of these warehouses or hospitals or whatever it might be. And then you say, well, but I need other things done. Instead of just moving boxes, maybe I need to clean the floor. Now you have two different robots. So we believe that over time, companies will end up here on the right-hand side, right? The multi-everything, multi-robot, multi-site, multitask, multi-vendor. Some people call it a multi-fleet. So anyway, so the idea is lots of different things working together, which is hard. The problem is, you know, you have one thing and it goes in a straight line, or maybe, you know, finds its path. When you add a lot of things and they're each following their own rules, it gets tricky, and it gets tricky exponentially. So we advocate for something we call orchestration, and we're like, what happens if you don't have orchestration? You have, you know, traffic jams, you have collisions, you have, you know, pissed off users. So we like to talk about the 4 O's. I'm not going to spend too much time on this, but, you know, it starts with knowing what's going on. So data, then robots don't run themselves. They still need supervision and people to jump in and help the robots every now and then. We talked about orchestration. How do you connect the robot with, not just make it work, play nice with other robots, but also work with systems that exist out there. And then the goal would be everything is optimized. I'm going to skip this, but essentially the state of the world today is there's lots of robots, lots of companies making robots. They go to a big company and they find all of these existing software systems, and you end up with something that looks like this, or, you know, I call it spaghetti. And as much as I love plate of pasta, that's not a way to run a warehouse. So we try to sit in the middle and be almost like the Google Translate of robots.
It looks like some of my code, actually.
Yep. I have I may or may not have written spaghetti code myself. Lots of it. So Stephen mentioned our robot space. It's in downtown Mountain View. For those of you who are local, you know it's on Custer Street, the pedestrian portion of it. Lots of people walking around, and it is literally a storefront. So we are technically a retail store, so you can buy some T-shirts and water bottles and things like that. But it's really an excuse to show robots at work. And I'm gonna do a demo of this in a second. But let me talk about how we approach this. So our idea is let's build an ecosystem. Let's work with different robotics companies and technology companies and service providers and put it all together. And then you end up with lots of different robots that do different things, which is fun. There are some emerging, I would say, to be generous, standards, specifications to help robots work together. We actually try to play in all of those. We do open source projects and contribute them. So if you're interested in some of this interop, there's ways to participate. We do a lot of community events at the robot space, whether it's talking about AI in robotics, whether it's, we have a picture here of the women in robotics, they held a meeting. We had students come in from high school and we said, okay, here's, $250,000 worth of robots, go run them using our software. What could go wrong? It was actually awesome. So we're trying to make it a little bit more accessible to people. I think this group is, highly educated on robotics, but the random person off the street, they, maybe have seen Star Wars movies or Terminator or whatever. And when you see a real robot, like a working robot, as I call them, they're supremely underwhelming to some extent, right? It's like, oh, that's a robot? It's like a cart that moves around. But it's also practical and it actually exists. So, we're trying to educate on that. And speaking of education, yesterday or the day before, we launched a completely free version, free for educators and students. And we have some partners that are using it. So again, same idea, get people working on robotics. All right. I'm about to switch to demo mode, unless there are questions or.
So are you saying the robots in Star Wars are not real? So
They're 100% real in a galaxy far, far away.
The
future's unevenly distributed.
Yes.
Yeah.
All righty. Okay. So we share. All right. So I talked a lot. Now let me show you some stuff. So this is our software with a imaginary customer called Brickmart. And Brickmart, you can think of them as, they sell little plastic bricks. But they're all over the world, right? And they have distribution centers, they have retail stores, and they have robots everywhere. In this case, they have 113 robots. So how do you keep track of them? So this is just like, if you have the any Lego movie fans here. So President Business, he's the boss. So I think of the CEO or the president of Breakmart as President Business. Anyway, obscure references aside, so this is kind of like an executive dashboard. Like you can't really do anything, but you can at least drill down here to our location, and you can already see different robots and different devices. But it's not an operations dashboard. It's just like a reporting dashboard. If you're an ops person, you want to see all the robots, right? You want to see the robots that are happy and the robots that are unhappy. And usually you don't care about the happy robots, right? So you want to see, show me where I have problems, or show me why the robots aren't happy. Show me incidents of, various severities. Let me drill down to, understand what problems are carrying over for too much time. That's one way to look at it, which is at the fleet level. Then you might say, okay, what, that's too broad. Let's go look at the robot space. Okay, so that's a little bit more manageable. I have a couple of unhappy robots. Let's go look at one of them. So now I can drill down even more. Now I get data from the robot, right? In this case, it happens to be a raw space robot. We're running our agent on the robot, but it could be anything. And then what data do you need? Well, you can configure. So you put these, whatever widgets you want here on the page. Here we have, we know how much battery it has left. Can track it over time. So, this is data. What most people tend to think is when the robot is in the lab and on your same network and you're SSHing into a robot and downloading data, everything's easy. If something is wrong, you get up, you kick it. How do you do that when you have hundreds of them, maybe in different continents, right? So how do you collect the data? How do you do it in a way that doesn't, overwhelm the network? What happens if the Wi-Fi that the robot is running on craps out for a little bit, which most Wi-Fis are not set up for continuous operation of robots. So we worked through all those problems, and we did it working with customers. But let's get to more fun part. So now we can see all of these different robots on the same map, right? And now we're getting a little bit more interesting data. So we have this robot, which is a commercial robot. You may have heard of a company called Mir out of Denmark. You'll find some number of Mirs in most locations. It's just a workhorse. It just moves around. Unfortunately, our camera doesn't seem to be working, so stuff happens. If I switch to this other robot, its camera is working right now. I can see also the point cloud from the robot. It's got a little LiDAR on it. So right now, one of the questions is, how do I see different robots on the same map?
Florian, what was that company name you mentioned?
Mir, Mobile Industrial Robots.
Who is it again?
Mobile Industrial Robots. It's a company out of Denmark. Was acquired by Teradyne, which is a Boston-based company, same company that acquired Universal Robots that most people know. So you have Universal Robots are the arms, and Mir are the mobile robots.
Thank you.
Yep. So let me show you. So we are hooked into the robots. Again, the robots make a map, and the map is based on their own sensors, right? So this is what this little robot, which is called Magni, from Ubiquity Robotics. Some of you may be familiar with them. So we have one of them. It made this map. When I switched to the Mir, it made a similar but slightly different map because it has different sensors. If I switch to this other robot back here, it made a slightly different map. So these are, if you've done kind of SLAM, these maps with all the rays sticking out, not very user-friendly. So what we do is with, we have what we call the pretty map that's annotated, more user-friendly. And then with the magic of math, we correlate and align everything. If you want to see what this looks like from a third-person view, we actually have in orbit has the ability to connect to other devices, right? So we have security cameras set up. And we can do, things like, for example, grab this camera. And if you want to see what Mountain View looks like right now, I think I can do this. Maybe this is a better view. So, I mean, it's just like a PTZ camera, but the fact that we can control it makes it, you know, more flexible. And the fact that it's all on the same platform means you're not switching from one to another. So let me try and go back to.
This is just for observability, that sort of thing, or can you control the robots from here?
Now, it would be a boring demo if it was just observability. So we're getting into that. So usually, like I can, you know, set a waypoint for the robot and I'll go there. But what we try to do is say, okay, so sure you can do that, but how are robots used in the real world, right? And I mentioned, you know, Brickmark is a retailer. So let's go shopping. All right. So, and this is, you know, when we talk to people, it's like, okay, have you ever wondered what happens after you hit buy on your Amazon order? And I've had the chance to tour an Amazon fulfillment center, fascinating, huge, you know, 1 million square feet operations. We have like a tiny version of that. So let's go shopping, and we have our little Orbito. It's our company mascot. So I don't know, give me a number between 1 and 5, Ralph. 3. All right. So we'll do 3 Orbitos. Let's get some water bottles. Steven, how many water bottles? 2. All right. Okay. So this is just square, right? Like we didn't build this, but I'm gonna use a little coupon here. So I don't have to type my credit card. It does want my phone number. All right. So I'm ready to place my order. And then when I do, a couple of things will start happening in rapid succession, right? So place order, that actually goes through a system called a warehouse management system. So that's a thing that knows where everything is in the warehouse, and it gets orders like the one that I just placed. So Inorbit talks to that thing, the WMS, and says, oh, there's an order that just came in. We're going to translate that into instructions for the robots. And it was too slow, and we already see one of the robots is running there. You can see here, this is what it's called a pick to light. Remember, we picked 3 Orbitos and 2 water bottles. So this is indicating the human operator what to pick. And the
So
robot knows.
This is happening real time, Florian?
It's happening right now in Mountain View. And then you can see Antonio here is using Inorbit on his phone to say, all right, I'm done with this order. And then, of course, if this were like a giant warehouse, there'd be robots zipping around, and Antonio could stay in one area, and he's the, you know, water bottle specialist. So he can stay on that. Now, some of you may have noticed that we were out of hoodies when I was trying to place the order. So we also send this robot to the back to pick up some hoodies to do restocking. You can see here, this robot, this shelf is empty. Now, here's the other thing. There's the front and the back. We actually control the door that separates the two. So we let one robot come in through the door, but what if both robots are trying to go through the door at once? So we have, you know, what's called traffic management. So this yellow area is basically a buffer zone. So we let this robot go through, and we make the other one wait. Again, this is, you could think it's not rocket science, but doing it across all these robots is something that's hard to do. So basically, this near robot, this guy is should show up here so that Antonio can add some hoodies to that shelf. So again, part of our motivation here is show real robots doing real work. So this idea of picking robots, there's a company called Brew Robotics. They just completed 2 billion picks. That's a lot. And they work very much like that little guy that we saw. But then you have to restock the shelves. So what do? Do you stop and bring things? Do you have different robots? So that's what we're showing here, is you can, have 2 different workflows coexisting. In the meantime, here's our picking robot. It's going to stop here, and presumably this would be like your packing station. Somebody takes everything, puts it in a box, and ships it to you. So this was like very kind of like one-to-one, one specific thing. If I pull back and I'm like, okay, remember we had like 100 robots across different places. Are they doing their job? So this is the idea of missions, right? So can you tell the robot what to do through a mission? Sometimes they complete the mission successfully, sometimes they don't, sometimes they have problems. So you can get data from all of that, and you can say, okay, just show me those robot space robots, and I want to see the difference between different types of robots and see if one is doing better than the other. Clearly, this guy is crushing it. This one, not so much. What's going on? And then we can look at an order from, I don't know, maybe yesterday. And we see, oh, okay, the robot, and this is what we call time capsule. So it's now we went from live to, trying to understand if something is working well. You can see, the robot can hear, waited at the shelf, waited a little bit for the door. So this looks like a happy mission. If you see like a giant red dot over here, then something's not quite right. So this is a way to have humans understand what the robots are up to.
Size of the dot implied duration of time.
Yeah, and we have like different visualizations, but the idea is make the data like a little bit easier to understand. All right, so that was one way to do it. Let me show you another use case, which I think is really cool. So this is with using a robot from our friends at Auto Motors in Canada. And this robot can do other things. It has new tricks that the other ones don't. So let's see if we can kind of see it in live again. So basically what I just did is I manually gave a mission to this robot by selecting an action. The robot is now completely autonomously navigating, and I said, go pick up this cart. And we did a demo to a hospital, and one of the problems they had was they have biohazard, right? Like a hospital generates a lot of biohazard on a given day. And you have people basically pushing carts from one end of the hospital to the other. What if we could do the picking for you, right? So this robot has a lifter. So it went under the cart and then picked it up. Again, we can't take credit for any of that. That's what the manufacturer did. They have a robot that can go under a cart and pick it up. What we're doing is we're wiring it with everything else, right? So in this case, the robot is it's not a really long, like we have a small space, but imagine that it went and picked it up and now it took it to the disposal area, right? So great, when it's done, I can, and we do have the camera going. So I think I can tell the robot to go back to its dock, right? And Yeah, so there's, it goes, it's coming out from under the table. Now, make things a little bit more interesting. I'm gonna take our restocking robot, and I'm gonna send it on, to the back to do some restocking, like we did before, right? And let's see what happens. I don't know if anyone remembers where the robot went to do restocking, but it went to the back. And it was like right there where the trash is now. So what happens, right? Is the robot going to run into the trash? That would be bad. That would be a really badly designed robot. So this robot has sensors. I think it's going to figure it out, right? It's going to go, okay, I need to go there, but that space is occupied. Now, it doesn't know what's going on, right? It doesn't have a concept of there's trash there, it just says occupied. It's going to wait and wait and wait and wait. And maybe, hours later, you come back and it never finished its job. So that's no good. So what we do is we know there's a problem and we propagate it. In this case, I'm going to use Slack. So we have a Slack integration. So it will Slack me when it gives up. It waits a little bit to see if it was like somebody walking by. And if not, it's gonna let me know on my on a Slack channel that I have set up. And there it is. Okay, so it says severity 1, there's an error. I can clear the error from Slack. The problem is the trash is still there. So I'm going to do it manually, but if we were, we could build the smarts into the system to have, this robot go return the trash to its original location, right? In this case, I'm returning the cart myself. I think I hit it, right? Yeah. Okay. So I just told that robot, you need to go pick it up. We could have wired it so that when the first robot detects that there's a problem there, it will call the other robot for help. So that way you don't need the human intervention. Now we're seeing one of the robots from the view of the other robot as it's going to pick up the trash. You can see it there, it's getting under the cart. And then once that's cleared, then we'll be able to, I guess I can clear the error. And then we need to decide, okay, do we retry once the area is clear? Robots are not the fastest things, but they get the job done. As you can see, that the trash is moving, it's spinning and going back somewhere else. So I'm going to, in this case, just clear the error pressing a button on Slack. And I think you saw the light change to green, so that's a happy robot now. And again, I could have that hooked up to this, but I'm going to say retry mission. Oh, I think I clicked the wrong robot. Yeah, user retry. All right, so yay, success, completed. So, yep, so that's part of what we do is kind of this lower level, get stuff done, and then higher level analytics and so on. I know, Ralph, you were saying something like, oh, it's a swarm of robots. I'm like, I don't know how many robots you need to have to qualify as a swarm. Like is 5 robots a swarm, or it's like 5 robots? I don't know.
It's
It's
at least,
one of
it's at least an assemblage.
Yes,
Right, we should create a whole hierarchy.
yes,
We should standardize on that.
Yeah, absolutely. Again.
yeah.
A collusion, a swarm, a murder, yeah. right.
So I wrote an article. So usually people call this fleet management, but I think of it as like, you know, you have some trucks and you want to know how much gas they're using. And this is, you know, a couple orders of complexity higher. So there was this whole discussion about like, what do you call a collection of robots that are doing a thing? And my proposal is a farm of robots.
Farm.
Yeah, nobody's using that except for me, but that's my thing because they're kind of like useful beasts that, you know, and in a farm you'll have chickens and you have pigs and they each have their own skills. But it's less than, and it's, there's this whole like, I don't know, in DevOps, you say, you know, pets versus cattle. That's a long discussion. It's like when you have a server on your desktop and then you have another one, they're your pets. They have names and personalities. When you have a data center, they're cattle. And
Right,
when
so
one of them acts up, you take it in the back and you shoot it in the head. That's the phrase from the DevOps world. So I'm like, that's a little harsh for robots. Like, I mean, you don't want to shoot a robot in the head.
I think maybe you have to choose depending on the type of robot and how you're using it and how intelligent it is, how autonomous, right? So a herd, could be a herd,
Could be a herd.
could be a flock, it could be.
There you go. There you go.
You know, a murder.
If they're in the water, it could be a school.
A school?
Yeah.
Yeah, sure.
Anyway, so
Preparation.
I think what today a lot of companies say, okay, I can take care of my own robots. But the minute you have different robots working together, it gets hard. And everyone says, well, if everyone does what I do, then it's fine. But of course, nobody wants to do what they do. So we exist in that kind of like, you know, middle ground that you know, you call it middleware, so that's appropriate. You know, we deal with the spaghetti, simplify that, and then we make it all work together. The alternative that I've seen is you do this by, you know, you have 5 different types of robots. They each come with their own screen. You swivel your head really fast between them and try to integrate everything in your head. Not good.
What could go wrong?
Very nice. So,
Interesting.
yeah, it's very nice. What kind of latency do you have for the video and the control and all of that?
I mean, video is very similar to what we're using, like Zoom.
Okay.
So this is good. So the answer is it depends on what you're trying to do. So for example, when we have robots like this one, for example, and it's sending its camera out. So the reality is for that kind of use case where you're just trying to figure out, is there something in front of the robot? Then we actually go through extra work to decimate the data, right? To have lower resolution, lower frame rate, because really that's all you need. And otherwise you're just wasting bandwidth. And you might think, well, I mean, we have high-speed bandwidth, but all of these warehouses have like ancient Wi-Fi systems. And then you try to deploy 100 robots doing 4K on the 8 cameras that they're loaded with, and you're gonna trash that network instantly. So we, you know, our marketing speak for this is adaptive diagnostics. So we try to adjust the resolution of the data to what you're trying to do. So if I start teleoperating a robot, then of course these things become really critical. So we'll ratchet up. And we have the ability, you know, you were asking, like right now we're doing with 68 milliseconds, so sub 100. You can see it here. So for example, if we try to do like actual teleop, you know, which we support, then if your round trip latency goes above some safety range will cancel out, right? So you don't want to be driving, and you know, these little robots are okay, but some of, you know, the bigger ones, you know, it's a one-ton machine. You don't want to, you know, think that you're, you know, 3 feet from the wall when you're actually are, you know,
Into it.
yeah. So we try to be careful that way.
Sounds good. Yeah. Yeah. Fascinating, being able to control multiple vendors, robots, right? It's really.
Right, and we're you know, incorporating more and more robots into the robot space and into our network. So we call it Norbit Connect. So the idea is, we say, Steve, right? Steve, you want to use 3 different types of robots from 3 different vendors, because one is like a forklift, the other one's a cleaning robot, whatever. If we already support 2 of them, then your job is a lot easier, right? You just plug them in and it works.
Mhm.
The third one, let's say you have a new robot, we'll work with you. It's free to you to connect your robot. And now you get the benefit of that. But then if Ralph now wants to buy your robot, now you already have it. So we're trying to make that as frictionless as possible.
So, Florian, is your business developing this orchestration software and consulting? Is that what you're doing?
We don't really do consulting where like we try to, unless we have to, you know, we're a SaaS platform for robot operations.
What's that, robot as a service? Is that?
That's a loaded term because we don't deal with the robots themselves. Like we don't make the robots, we don't sell the robots. They're your robots or they're somebody else's robots. We just help you manage them more efficiently. So it's a service, if you think of it, on top of the robots to help you squeeze more productivity out of them.
So what does SaaS stand for?
Oh, it's a software as a service.
Software as a
RAS is copying SaaS. SaaS came first.
Now you're getting sassy.
So what are you adding next?
So we have, I don't know if you saw it, there was a black robot in the corner. That's really cool robot from a company out of India called Brew Robotics. And what I really like about it, I mean, superficially, it's the same as the others. It's, you know, a flatbed that moves. This one has a couple of more intuitive ways to work with it. So you can, it has teach and repeat. So basically you move it around, it remembers, and then you say, do that 100 times. So there's a number of robots that do that. This one, what I think is really unique is, let's say it's moving autonomously. And let's say it looks like a flatbed, right? It has a handle. If you hold the handle, it will know that you're there and it will slow down and let you drive it. It's still powered. It's still not going to let you run into the walls, but you're driving it. And then when you let go and you're like, okay, go back to what you were doing, it goes back. So I think that's a really natural way of interacting with robots.
Kind of compliance.
Yeah.
Compliance based on sensing.
Yeah, you know, haptics.
How does it sense you're holding onto the, you know?
I think it's just like from friction, like is it
So kind of straight.
sensing resistance?
Right? That's all.
Yeah,
You're pushing on it.
yeah.
Yeah.
So I actually don't know how it works. I just know that it works. And this is like just a really cool company that is just getting started. And by having it at the robot space, like we do like 5 to 7 demos a week, right? So we're always like either in person or remote, as you saw today. So we just give them more exposure to potential customers. And that's growing. We're now working with SICK to install more sensors. So really trying to, this abstract idea of ecosystem, try to make it a little bit more concrete. We're not going to be able to have every robot that we work with there because then that becomes unmanageable, but at least an interesting sample of robots.
So you have good documentation and of the API. Do you have like a open source library that you can integrate easily into a new robot?
Yep. So we have SDKs on the robot side. We have APIs. We have pre-built integration. So reasonable ROS1 and ROS2, like Logic, whatever. That's like off the shelf. If you have a robot, like just download it.
So
Most of the time, yeah.
I'm
Go
sorry, I
ahead,
didn't want to interrupt. Go ahead.
I was just gonna say, with ROS, for example, you can most of the time introspect and find out what data sources, right? What topics are out there. So it's a little bit easier. If you handcrafted your robot from scratch, you need to do a little bit more work to tell
So
us.
in that sense, I think we'd agree that ROS is like the standard framework for robotics. And I'm always on the lookout for anything that's on the horizon or competition. And other than like NVIDIA's Isaac robot engine and Cynthium, for example, and VM. I mean, I don't know if BrainCorp uses ROS or not, but I mean, what is there that's like a framework besides ROS?
I mean, I think with NVIDIA, even NVIDIA kind of pulled back on Isaac as a competitor to ROS and said, no, actually, let's play in the ROS world. So I think ROS is eating the world. But I also run into people who are extremely proud to have built the whole robotic stack from scratch like 4 times. I'm like, why? I don't know. Maybe because
Like
it's
Martin
fun.
Triplet,
So
in-house
again,
joke.
I think the idea is, if you want to go fast, ROS is probably the best way that we've seen. It may not meet 100% of your needs, so you may need to tweak it from there.
Yeah, it seems like it has a lot of overhead still. Like ROS 2 is better than ROS 1,
Yeah.
but it still seems like it has quite a bit of overhead.
Yeah.
So I think people who are probably going around it are probably sensitive to that overhead.
Right. So we actually, in some cases, we don't even talk to the robot itself, but if the robot has an API that it talks over HTTP, then we'll talk to that. Or if it comes with a fleet manager that allows you to manage like 10 robots on site, then we'll talk to that thing. So our idea is we're as agnostic as possible. We want as many robots and robot types as possible.
Yeah, I was gonna ask you, what were some of the challenges you might have had with, integrating different robots into the system and different vendors?
Like the mapping thing that you saw, like it's like, well, no, it works. It took us a while to get it, fine-tuned and make it, as intuitive as possible. And now we're adding new things on top of it. But a lot of what we've done has been working with customers, and they're like, well, my robots work in a crappy Wi-Fi, and when they go to that corner, they lose connectivity. We're like, Then we came back with this idea of, data backfill, right? So it'll record locally on the robot, and then when it reconnects, it just like uploads all the missing data. That was, again, working with customers. Now that I say it, it's kind of obvious. Maybe we could have figured it out on our own, but when it comes from a customer, then it's like, well, at least somebody needs it. And then you ask around and it's like, how is your network? Is your network good? And it's like, oh, it's really crappy. So we realized that it was a common enough problem that it merited like a standard solution.
Yes. Yes, well.
Yeah.
I work for a number of large data centers and so on as a DevOps with thousands of virtual machines. And instead of virtual machines, we have robots here. So there is a lot of parallel architectural issues to deal with. So my question is, where is your central system, how it is distributed to make a failover and the backups and so on, and what operating system you are depending on the basis?
Yeah, so I mean, it is very similar. That's what we call this RobOps versus DevOps. The difference is you can't instantiate a robot like, instantly like you can a VM. We run in the cloud, so we take advantage of the fact that the cloud is distributed and we have different availability zones and so on. We actually run on multiple clouds, like different vendors, because some customers are particular, like, if you're a large retailer, do you really want to work with someone who sends their data to Amazon? Maybe not so much. Rest of the people don't care or have a preference, so we had to adapt to being multi-cloud. OS doesn't matter, but it's all Linux anyway.
I had a question, how about integrating new robots? I mean, it's such a heterogeneous number of different kinds of robots. I mean, especially if it's well, even in ROS, you have different published topics and all that, and then in non-ROS, you have something else. How I guess do you work with the vendor of the robot, and they both kind of work on this problem and fulfill a set of, say, API requirements or some kind of, go down a list of, robot must comply with this standard, that standard, fill in the code and something like that? Or how do you do it?
So we, as much as possible, try to adjust to what the robot does. And then we also try to give the power to the robot developer, right? They're the ones who know their robot best, and they know what data makes sense. So like even something as basic as battery, right? Like some people will report percentage, others will report voltage. What's the right way for your robot versus what's right for someone else? We don't know. So what we do is we allow you to configure things. So a couple of things that I'll show here. One is when we're talking about documentation, we have a robot SDK, you can learn about it. We have, if you're building something from scratch, right, then you can work on those, C++ bindings. For ROS robots, we have different versions of our software that supports, the typical permutations of, Ubuntu and whatever. And then somebody comes along and says, I use Yocto. It's like, all right, let's go work on that. And then now everyone who uses Yocto can take advantage of it. If you have truly a one-off, you can use the SDK. Mostly what you need to do is you need to say, okay, I have these data sources. This is the data source for battery. This is the data source for pose. Here's how you read them. You can create a republisher to adapt. So there's a little bit of upfront work if you're running on the robot. If you don't want to run on the robot, you want to use this what we call the Edge SDK, and you have a external API, external to the robot API, like over HTTP. Then you can build a connector. The connector is, again, just like a simple translation layer, and we take care of all the connectivity and all the more complex things. So we try to make it as easy as possible. Once you have the robot at least connected, what I wanted to show you is you can go to settings and you can define this in code or directly here. But, you know, you get a bunch of data sources and you can specify which ones you want, which ones you care about. And then let's say your battery, you want to be, you know, configure the battery notification to be at a certain level, or you know, when your CPU hits a certain number, you want to trigger an alert. So we try to push all of this so that you can configure it yourself. Again, for more complex configuration, we use configuration as code. So you write like a JSON file or YAML or whatever and push it through our API. And you know, it's version control, all the nice things about configuration as code. So we try to make it as painless as possible to onboard a new robot.
Sounds good. All right. Well, I think we covered everything pretty well. Any other questions? Excellent. Very nice.
Yeah.
Awesome.
Can't wait to try it.
Once again, if you're local or if you're visiting, we're on downtown Mountain View, 293 Castro Street. We're open some afternoons to the public,
Okay.
but I'm Florian at inorbit.ai. So if you want to come hang out, geek out, then shoot me an email.
Do you have a sort of a minimum viable controllable robot suggestion? Like, you know, a kit and a camera and software.
Like a turtle bot
Okay.
with a Raspberry 4 is like a good starting point. That's,
Yeah.
you know, maybe $100 or sorry, $1,000, like all in, like with the lidar and everything. If you want like a fully functional robot.
Actually, Turtlebot 4 is up quite a bit. It's like 1,200 and 1,800 if you want the tall one.
Yeah,
If
we
you
had
think
a
you can
bunch
get
of the
them.
burgers, and those were really economic, right? The TB3s, the burger.
I'm talking
Um,
about a real Turtlebot.
If you have more money to spend, we really like that Magni from Ubiquiti,
Yeah.
because it's still researchy, right? But everything is open, everything's open source. But
Ubiquiti
it
Robotics.
can carry, yep, it can carry, you know, some actual weight.
Yeah.
They say 100 kilos. I haven't tested that, but it's a tiny
Step
robot.
right up.
Yeah.
We used to see David riding into the meetings, standing on the thing.
No, I know. And he's so tall, so I don't know if he falls, he's gonna kill himself. But yeah. But then I mean, some of the robots that we have there are like, you know, 45 grand.
Right.
Like they're
Yeah.
commercial.
I think they get more interesting when they get less expensive. So
Yeah.
So we should.
Homebrewed robots have personality. All right. Thank you very much, Florian. That was an excellent presentation.
Awesome. Thank you. Thank you so much. And
All
I
right,
don't know how, I have not become a member yet. So
There we
what do
go.
I need to do about?
Oh, you send $10 to Dan Tepler.
Right.
Dan's not, yeah.
Yeah.
Join our mailing list, Florian.
We'll do. Yeah,
Yeah.
we'll do, Cam.
Yes, so that, yeah.
All right. The next segment of the show is the show and tell. What do we have for show and tell? Don't everybody speak at once. You know what happens when you don't have any show and tell?
Oh, God.
Yeah,
Somebody has shown.
Yeah, I
Yeah,
got
but-
something, Cam. Yeah, I always have something,
Thank you, Thomas.
just like you.
No, you gotta
Yeah,
listen
just
to
like
me
you.
if you don't have any show
Does
and
this
tell.
thing count? Is this a robot? Is this?
Cam, can you hear me?
Needs wheels.
Hello, testing.
Yes, we got you. We got you, Thomas.
Oh, all right. I wasn't sure whether it was working. I just have a real brief thing.
I got
A few,
wait, let me highlight you otherwise. Because you're talking on the other device.
I am.
Yeah, bear with me.
Highlight the right device.
Yeah, that's always a problem. Let's see where you are here.
HBRC host.
HBRC host.
Yeah, don't you see my picture? Look.
I see you, but that I only get an option to rename. Hey, can you
Oh, wait, let me see if I
can
can.
you spotlight yourself?
Yes. I didn't know I could. All right. I just had you challenged me about a couple months ago with the new Arduino, and so I met the challenge, and you said, can you program it, the LED display? Yeah, you've seen this already, Camp. Most haven't. So I programmed the LED display on the new Arduino. This is the R4. It's not there. We go HBRC.
There you go. Yeah.
We're hard to impress, but easily amused.
That's what I was counting on. So yeah, these things have a real-time clock, and they have it's either 4 times more memory and 10 times as fast, or the other way around. I don't remember. And they use a different chip and a Wi-Fi. This one has Wi-Fi. That's an option for an extra, I don't know, $5 or something. You get Wi-Fi, and I think it might have Bluetooth, but I'm not certain. I haven't looked that deeply into it. And it's programmed like all the other Arduinos. So it's got the place for the shields on top. So it's really a sweet deal.
What model is that? What's the model of Arduino?
That's the Arduino Uno R4. R4 with Wi-Fi. They come with and without Wi-Fi.
Romeo 4 with Wi-Fi. Very fine.
All right, that's all I have.
All right. So let me show something real quick here. Share screen. So with the Ross discussion group, I've got a new computer that's really fast. It's an i9 processor. I picked it up for $650 on eBay. The i9 with 12 threads and 6 cores. I had problem running Ubuntu 2204 and Humble. Seems like it takes a lot more horsepower than Foxy. So with my simulations and visualization. So here goes Gazebo for the Lino robot. Let me put Lino robot in the chat. For intermediate ROS, this Lino robot's really good. I'd recommend doing the bot vac if you want to start off with ROS for mapping and navigating. I'm going to put the link for Lino Robot 2 in the chat. If I can find the chat. So here's Gazebo, and that's the little Lido robot in there. We've actually expanded it. The stock robot's 10-inch square with 3-inch wheels. We've modified it with a 20-inch base and 5-inch wheels. I also flip-flopped the LiDAR and the camera. They had the LiDAR high and the camera low. LiDAR should be low because obstacles rise from the ground up, not from up down. So here comes RViz, the Ross visualizer. This is the world as the robot sees it. Oops, I just lost it. Sorry. I launched another instance of the gazebo. So these demos are going to be limited to 5 minutes. So if I can't get it done in that time frame, we'll just adjourn. So here comes the RViz, the Ross visualizer. So there's our robot in RViz. Here's our robot in Gazebo. I'll load in the nav2 stack. The navigation stack has all the planners and directors and recovery behaviors. And then finally, I'll put the teleop keyboard handle here just to drive it around. So this Lino robot is something we work with in the Ross discussion group. Again, here's the Gazebo. Here's the RViz, the Ross visualizer. I'll bring up my teleop keyboard. We'll drive the robot a little bit. So this is actually quite a bit of processing here. My dual i7 Dell, which is no slouch, couldn't handle this. This i9's taking it pretty good. Let's look at HTOP. This tells us about the performance. I've got a load average there of 32, and this guy's handling it pretty matter-of-factly. Let's drive up to our cone here. The Lino robot's good because they've got the Gazebo, the simulated model, and then they've also got a physical counterpart with standardized motor drivers, LiDARs, cameras, stuff like that, and an active user community. So this is like intermediate level Ross, the Lino robot too, and I'd recommend it. So here we are with the Gazebo, and there's our Lino robot there. And that's it. Any questions? What else? Somebody else got a show and tell? Well, I got one more then.
I'm installing Ross, but I don't think that's going to be very exciting.
Oh, that's very exciting. So let me exit this stuff here. Question?
What's your password?
Yeah, what's your password, Cam?
No, for comments.
It's password. So I've got a bot fact down here. I don't want to do that. And I'll ping it just to make sure it's there. And then I'll SSH to it. That's the Raspberry Pi inside the dirt bin. Then I'll launch the botvac package. That's where the Raspberry Pi is talking to the botvac.
We don't see your screen share, Cam.
Thank you. So this is Flam toolbox with RViz, the Ross visualizer. I run that on the workstation. I run the BotVac package on the Raspberry Pi. Seems to be giving me some errors. We'll just try and forge through this. So here's my BotVac here. This is an actual physical robot. And so I'll drive it. I almost crashed into the wall there. Anyway, so here's the robot, and to navigate, we click on 2D nav goal and 2D nav goal and point press drag mouse up, and the robot will autonomously navigate back. And that's it. It's navigated back to its it made it to the goal. All right, what else? Anything else this evening? Florian, I want to thank you very much for coming out. I want to thank you guys for coming to Maker Nexus. I guess we'll be adjourning now to random access unless anybody else has anything else they want to say or make any comments. All right, a motion the meeting be adjourned. Do I have a second?
I second.
Second the motion. All in favor say aye.
Aye.
Those not in favor say nay. The ayes have it, meeting adjourned. Thank you, had fun.
Bye, everybody.
Hey, Thomas, you can turn off the recording.
Alrighty.
Thank you again, Florian. Stephen, thank you. Ralph, thank you. We had some fun.